today's episode of Time Travel News. We have brought together two of the first scientists to publish ideas on how species evolve or change over time. Visiting us from the 19th century are Jean-Baptiste Lamarck and Charles Darwin. Monsieur Lamarck, let's start with you.
I was one of the first to recognize that species change over time. In 1809, I proposed the first theory of how species change over time. Allow me to explain my theory. Let's begin by talking about giraffes. Frank, why do you think giraffes have such long necks?
Well, to reach the leaves at the top of the trees, I guess. They all have to get the food.
Quite right. I began to wonder why giraffes' necks became so long. My theory was that giraffes stretched their necks by reaching for the leaves that were higher and higher on the trees. This made their necks longer. Then when they had the babies, their babies had longer necks too. Look, this sketch helps explain my ideas.
Shouldn't a theory be based on evidence?
Mr. Lamarck, did you ever see a giraffe grow its neck longer?
Of course not. My idea was that the growth was very, very small. Too small to measure in one generation.
Well, I'd like to explain another theory called natural selection. Alfred Russel Wallace and I constructed this theory at about the same time. We also noticed that not all animals of the same type have the same features. Take horses, for instance.
Oh, I know what you mean. There are horses of different sizes and colors, but they're all one species and can be interbred.
Exactly. And the same is true of giraffes. Have you noticed that animals in the same species look different or varied? Have you noticed? This is important because in the wild, some animals in each species usually die every year. Only animals that survive can give birth to more offspring. Now, what feature of a giraffe might help it to survive and reproduce?
Its neck, of course. As I said before, it must stretch from being used so vigorously. Giraffes can then pass on their long necks to their little baby children.
But, Mr. Lamarck, modern scientists have found literally no evidence for your hypothesis that parents can pass along an acquired trait to their offspring. I mean, consider professional wrestlers. They build their muscles by lifting weights. Kind of, like me. But their babies they're no stronger than other babies. If these babies want to have muscles like their parents, or me, they have to pump a lot of iron too.
But just like human babies, not all giraffes are the same. They have slight differences in all their characteristics, including their neck length.
So, you are saying any giraffe that happens to have a slightly longer neck can eat leaves that are higher up in a tree than a shorter necked giraffe, and therefore is more likely to survive.
So, the long-necked giraffes are more likely to live longer because they can reach all the food. If all of these giraffes live longer, they can produce more offspring.
That's right, Hank. Animals with certain features, such as giraffes with longer necks, are more likely to live to adulthood and have more little giraffe babies. We call this process natural selection. Here's a sketch of how it works.
But why will all the long offspring of long-necked giraffes have longer necks too?
Well, tall parents are more likely to have tall children, aren't they? The same's probably true for giraffes.
According to my theory, each new generation of giraffes has, on the average, slightly longer necks than the generation before.
Only, but not because they stretched their necks. Only because the long-necked giraffes were more likely to survive and reproduce.
I get it. Individual animals don't change, but over a very long period of time, the population of entire species does.
But Mr. Darwin, can your theory of natural selection explain why extinction occurs?
Mr. Lamarck, I believe so. Consider the mammoth, which became extinct a few thousand years ago. Why didn't mammoths keep changing and continue to survive?
Well, there are several theories on that. They became extinct during the time when the global climate was warmer than it was before. The changing climate may have affected the mammoth's food supply, and human hunters may have contributed to their extinction.
So a species becomes extinct when it doesn't survive an environmental change. No individuals in the population have the traits necessary to survive.
That's all it is. The variation in the population isn't enough to withstand environmental changes. In fact, sooner or later, most species become extinct.
Let me get this straight. As time passes, species change. The way this occurs is by natural selection. Some individuals in the population happen to be better suited to the environment, and they're more likely to survive and to reproduce.
And as a result, the population as a whole, over many generations, comes to have the trait, such as a giraffe's long neck, that increases their survival. A trait that becomes more common because it increases their survival, and reproduction is called an adaptation.
Today we know that we pass on characteristics like longer necks to our offspring through genes. Genes don't change because you exercise your neck.
Please tell us more about these genes.
I learned about genes in school. Genes are part of our cells that we inherit from our parents. They determine our traits like hair color and eye color.
Well, that is fascinating. I would like to learn more about this.
Without this modern evidence, I hesitated to publish my theory for years and years, until Wallace sent me a brief paper containing the same ideas. Within a few years of our publications, our ideas were widely accepted.
So scientists now understand that natural selection is the process that results in the survival and reproductive success of the individuals that have the inherited traits. Now that we see that those inherited traits are adapted to their current environment. Thank you, Mr. Lamarck and Mr. Darwin. And I hope, viewers, you've enjoyed meeting some people from our past. Join us next week for a scintillating conversation with Marie Curie, the first woman scientist to receive a Nobel Prize.